Hello, welcome to Accounting Hub. I'm Professor George Scarpin, PhD in Accounting, and our topic today is Poisson Distribution. So, another distribution for discrete values, just like binomial distribution. And by the way, we have a video about binomial distribution on our channel. The video is in our video description. But Poisson distribution models the number of occurrences in some units of measure, often time or distance or number of time or number of customers or any numbers but 1, 2, 3, 4, and so on. There is no limit on the number of occurrence. The average number of occurrence per unit is a constant, and this huge formula for the probability mass function, we will not be working with this huge formula because we are going to do that on Excel much easier. And an experiment satisfies a Poisson process if the number of successes with a specified time or space interval, number of days for instance, equals any integer between 0 and infinity. So, okay, we have the average number of customers that go into a business is 35, 40, but cannot be negative. So, between 0 and plus infinity. The number of success content in non-overlap intervals are independent. So, there is no just like if I go to a store, I go to a restaurant, so it must be independent. And the probability of success in any interval is the same for all intervals of equal size. It is proportional to the size of the interval. What does it mean? For instance, the average revenue for a business is $30,000 in a 30 days period. So it is $1,000 per day. So it is proportional to the size of the interval. Okay, so there's no seasonality and so on. So examples, the number of customers who use a new banking app in a day, etc. And okay, we are going to Excel. What is the formula? Poisson distribution. X, mean, and cumulative. What is the cumulative? If it is true, we are talking about the cumulative distribution. At least 5, at least 10. So it means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Or false, exactly 10, or exactly 12, or exactly something. So let's go to our Excel data. So what do we have here? What is our situation? Gabby is let me delete the charts. Or better, let me delete everything here. And let's work on it later. And let me delete one. The other will be the same. So, okay. Now we are good. So Gabby is concerned about staffing needs at the restaurant that she manages. She believes that the typical customer averages 15 visits to the restaurant over a 30-day month. So half visit per day. And then some questions. So 30 days, 15 visits. How many visits should... No, it's not any. It's Gabby. Gabby, my daughter. So how many visits should Gabby expect in a 5-day period? Typical, not a Starbucks, a typical restaurant. Oh, come on. Okay. So, if we are talking about 5 days, the average will be 15 visits divided by 30 days times 5 days. So 2.5 visits. So this is our required A. Required B. What is the probability that a customer visit the chain 5 times in a 5-day period? So, okay, visit uh, 5 times in a 5 days. So if it is a 5-day period, we work with this average instead of this one. So we work with this average here. So let's go. Great. And then, okay, I don't want at least 5 times. I want exactly 5 times. So it is the F, X, where X is the number of times, and capital F is for cumulative. So what do we do? Insert function. Let's go all. The easiest way, type Poisson here. What is the difference between Poisson and Poisson Dist? Poisson is with Excel 2007 and earlier. We are a newer one, so Poisson Dist. What is the X? Number of times. Mean is the average, so F. 4. And cumulative, no, false. So here, exactly 0, exactly 1, and we go until 15. We don't need more than that. So we want here in a 5-day period, so exactly here. So the answer in yellow. Let's go on yellow. Whoops. Not you in yellow, you in yellow. So the probability is 6.68%, almost 7%. Letter C. What is the probability that a customer visits the chain no more than 2 times? No more than 2 times, we are talking about cumulative. 0 is no more than 2. 1 is no more than 2. 2 is no more than 2. So the answer will be the green here, 2. How do we do it? Let's go to the Poisson formula again. So then, mostly use it. X, the same. Mean, the same. And F4. Cumulative, true. Let's go on capitals. True. Okay, so the same 0.8 and Y is the same because cumulative, just like any other accounting cumulative, beginning balance plus current period. We have no beginning balance, so it's the current period. And then let's go here and then go on green. So 254% of probability that at least 2 or no more than 2. And letter D, what if there is a new menu that could change the average to 21 visits? So we will be better because the average will be 3.5. And doing the same formula, in a 5-day period, it's moved from 006 to 013. And at least 2 decreases from 54 to 32. Is it good? Yes, because the 54 is around here. The 54% is not going at a maximum of 2 times, but maximum of 3 times. So more times they are going to our restaurant, more revenue. And then the average goes up. That is why it's better. So let's chart it. So exactly the current, the new menu, and then let's do the cumulative as well. Current and the new menu. And let's copy and paste. Okay. Yeah. So let's double check here. Comes 16, perfect, because 0 until 15, so it is 16. And then let's see how do we charge them. So come, insert, column, column. So this is the, oh, come on. Let me move myself over here. So here's the chart title. See the new menu. My Poisson distribution is more to the right. And the more to the right, the better. So here we have the exactly. And then the cumulative that looks like a Pareto chart. That goes. That goes here. Cumulatives. Look that it takes more time for the new menu to go up. Or the clients goes more time to our restaurant. So here we can move better on staffing our restaurant, for instance. So we can do it, and we can do it not very easily, but not that hard creating these charts. Okay, guys, that's it. Thank you so much. Questions or comments, leave it here or email me at jscarping@gmail.com. Let me move myself over here again. Have a very nice day and God bless you.